In this video, we're going to look at how to calculate the asymptotes of rational functions as they occur in the Further Studies Maths program. First of all, you could get a vertical asymptote on your graph, and this asymptote will occur where your denominator of your function is equal to 0. You could get a horizontal asymptote, and to calculate the equation of the horizontal asymptote, you want to calculate what is happening as x tends to infinity on the function. You will get a horizontal asymptote when the highest power of the numerator is either the same or less than the power in the denominator. Then you could get an oblique asymptote. An oblique asymptote, you are going to resolve the fraction into its parts, and that will help you find the oblique asymptote. That's just one of the methods, but it's definitely the easiest method to use, and that's the one that we will look at in this video. Now, the oblique asymptote will occur if the highest power of the numerator is more than the power in the denominator. In other words, we cannot get a horizontal asymptote and an oblique asymptote at the same time. Let's look at the following example. F of x is equal to 2x plus 3 over x plus 1, and we need to determine all asymptotes of f of x. Well, first of all, there's a denominator, so there will be a vertical asymptote, and that will occur when that denominator, x plus 1, is equal to 0. In other words, there will be a vertical asymptote at x equals minus 1. Then we need to decide, will there be a horizontal asymptote or an oblique asymptote? Well, the power of the numerator is the same as the power of the denominator, so we will have a horizontal asymptote. And to calculate the horizontal asymptote, we need to figure out what is happening as x tends to infinity on this function. One of the ways to calculate the limit as x tends to infinity of a function is to take out the highest power of x as a common factor on the top and on the bottom. So in the numerator, the highest power of x is x, and in the denominator, the highest power of the denominator is also x. So if I take them out as common factors, those x's can cancel. Then we need to decide, if I substitute infinity into 3 over x, I will get 3 over infinity. And we should remember that that will tend to 0. The same in the denominator. If I substitute infinity into 1 over x, I will have 1 over infinity, and I know that also tends to 0. In other words, all I'm left with is the 2 over 1, which means I will have a horizontal asymptote along the line y equals 2. With some other calculations, your function will look like that, just a hyperbola. Let's look at the second example. F of x is equal to x squared plus 2x plus 1 over x minus 1. Now, the first thing you want to do is just make sure you can't simplify the function, because that will make it a lot easier to work with. At this stage, we can't. So we're going to look at the asymptote. The vertical asymptote occurs where your denominator, so x minus 1, is equal to 0. In other words, you have a vertical asymptote where x is equal to 1. Now in this case, will you have a horizontal asymptote or an oblique asymptote, or neither? Well, the power of the numerator is higher than the power of the denominator, so you will have an oblique asymptote. And to work this out, we're going to resolve that fraction into its parts. Now, the easiest way to do it is you want to try and simplify that fraction as far as you can, resolve it into its parts. So you want to take out the denominator as a common factor in the numerator. So you have to ask yourself, how can I get x squared if I have to have x minus 1 in the bracket? Well, I take out x as a common factor. If I multiply that x back into my bracket, I'm going to end up with minus x. Now I need to correct that, so I'm going to plus x, and then we just add the rest of the numerator. So plus 2x plus 1. The x minus 1 in the first term can cancel with its denominator, and then we're still left with 3x plus 1 over x minus 1. We can resolve this further by taking out a common 3. But if I multiply that 3 back into the brackets, I'm going to end up with a minus 3 that I never had before, so I'm going to correct it and add the rest of my numerator. The x minus 1 in that numerator can cancel with its x minus 1, but I'm still left with 4 over x minus 1. You can't resolve that fraction any further, so your oblique asymptote is y is equal to x plus 3. And with some further calculations, calculating the x-intercepts, the y-intercepts, and the stationary points or turning points, you will have a graph that looks something like that. Thanks for watching Max Maths. If you liked what you saw, please like, share, and subscribe.